Welcome to International Observe the Moon Night 2021. We are sharing some live views as we wait for the event to get started. Our moon is currently around an 86% waxing gibbous, so it's on its way to a full moon on Wednesday. We'll resume some views of the moon later on during the program. I'm going to give it a couple more minutes for a few more people to join. In the meantime, I am going to share with you so that we can at least see the moon for a little bit from rainy Montreal. We have our lovely moon visible from the Observe the Moon site. They've got a live feed for the entire day, which has been great. We don't get to see it, but Stephen has some lovely skies out in Calgary, so I'm hoping he'll take some pictures to share with us online, if not at the end of the talk when we open up to Clubhouse again. Hey, Felicity, thanks for joining us.
Very nice to see something in the sky.
Yes. Well, those clouds were for making some amazing patterns earlier in the year, or earlier in the week, sorry.
Hey, how lucky can you be to get a meteorite in your bedroom?
I saw that. That was incredible. And it missed her, thankfully.
Yeah. By seconds, apparently.
If you're not aware what we're chatting about, a lady in BC woke up with a fragment of a meteorite on the pillow beside her in bed.
And it's not that small.
No, it was a substantial hole in her roof.
Actually, my reading was that it was in Hamilton. Maybe I'm wrong.
Well, we at first thought it was in Alberta somewhere, but no, it was in BC.
Yeah, I saw BC.
And supposedly her dog was barking, and that's what caused her to leave the bed. And that's when it hit.
Excellent. All right, so I'm going to go ahead and I'll ask everyone to mute, and we'll unmute people as we go through. So welcome, everyone. Thank you for joining us. My name is Kareem Jaffer. I'm the Public Events Coordinator for the RASC Montreal Center. And tonight for our International Observe the Moon event, we were optimistic and we hoped for actually having a view of the moon at nighttime. So we thought we'd have a late afternoon event. We have Chuck Allen with us from our local center as well as from the Astronomical League. And he's going to share with us some thoughts on the solar system moons as well as the dwarf planets in the solar system. But before we get there, we do want to start with our traditional land and sky acknowledgement. And our land and sky acknowledgement, what we express here in Montreal is that we are on the traditional territories of the Mohawk and the Algonquin peoples. And we thank them for, having taken care of the land, and we recognize the contributions of the Métis, the Inuit, and the other Indigenous peoples. But in the RASC Montreal Center, we also recognize that we share the sky with them. And specifically because it's International Observe the Moon Night, we share the moon with them. And I managed to get a picture of the moon from one of my colleagues in the UK from Astro Radio, Roger Hyman. This is the moon from about an hour and a half ago. It's an 85% waxing gibbous. And in a few days, we're going to be at the October full moon, which this case is the animal fattening moon as known by the Mi'kmaq. And so what they call this moon is Wagewagoose. So their names for the moons recognize the association with the moons with what they see in nature around them. And I highly encourage people to take a look at the Mi'kmaq Moons project from the RASC from a few years back. Now, before I go any further into the RAC Montreal Center, we are delighted to have with us today, as we've had many of our events, our honorary president, David Levy. So I'll ask David to give us a welcome and a reading for tonight. David, you are muted, unfortunately. Yeah, we can hear you now.
Well, okay, good. Thank you very, very much. And it's wonderful to be here. And since Halloween is coming in a couple of days, I will try to use my best Halloween scary voice as I quote to you this poem by Edgar Allan Poe. It is not The Raven, and it is one of his least known poems, and it is also his longest poem. It is called Al Araf. And what Poe did was that he was a member of the Montreal Center of the Royal Astronomical Society of Canada. Did you know that, Kareem? No,
I
the
did
Montreal
not.
Center did not exist.
Exactly.
So I lied. He was not
We're
a
not quite
member of
that
the
old.
Montreal Center, but I believe that he would have been if he had known. Anyway, he had a telescope and he enjoyed looking through it. And he also enjoyed the history of astronomy, particularly the discovery by Tycho Brahe of a supernova of a new star in the year 1572. Al Araf is his longest poem. It was roundly criticized, and as a result of that, he decided to make the rest of his poetry a lot shorter. And so this is a great favor to many of our undergraduates who study Poe right now, are blessed with his short poems. Anyway, I'm going to quote from Al Araf. Oh, nothing earthly save the ray thrown back from flowers of beauty's eye, all the flowers that list our love and deck our bowers, adorn your world afar, afar, the wandering star. Spirit that dwellest where in the deep sky, the terrible and fair in beauty vie, beyond the line of blue, the boundary of the star, which turneth at the view of thy bower and thy bar, of the barrier overgone by the comets who were cast from their pride and from their throne, to be drudges till the last, to be carriers of fire, of the red fire of their heart, with speed that may not, and with pain, and with all the pain that shall not part. Who livest that we know, in eternity we feel, but the shadow of whose brow, what spirit shall reveal. Enjoy your Halloween. Let's enjoy our evening tonight. And back to you, Kareem. Thank you.
Thank you so much, David. That was fantastic. I love Poe. Poe is one of my favorites. So the RASC Montreal Center, for those of you who don't know too much about us, we are over 100 years old, so not quite as old as Poe. We are a very strong and vibrant center. We have been active through COVID. We were one of the first centers to switch immediately onto a virtual platform. We're one of 29 centers across the country for the Royal Astronomical Society of Canada. We have an observatory at the Morgan Arboretum. We have a dark sky site close to the US border. And then we have other sites that we use on and off the island for different types of observing events. We also have a library at John Abbott College, which is currently unfortunately off limits. And we do outreach as well as public events, as well as our members events that we do annually, as well as some of them weekly. We have many different observing programs that we do with the National Center. And so on that note, I'm going to stop sharing and I'm going to invite our members liaison, Nicole Laporte, who's going to talk to you about our Explore the Moon certificate. Nicole?
Hello. Yes, I'm going to talk about the Explore the Moon certificate because today is Observe the Moon International Day. I'm just going to share my screen. Okay, and I'll start the slideshow. Can you see my screen?
We can. We see the whole PowerPoint.
Okay.
Not just the slide. There we go.
Okay. So, yeah, I'll be talking about RASC Explore the Moon Observing Program. And you might ask yourself, well, why look at the moon? Well, the RASC Explore the Moon is an introductory observing program. It's developed to encourage amateur astronomy through visual observing and recording. So for this program, you're asked to look at some craters and other features and to record them. And that's an important part of astronomy, is recording your observations. And there's 3 good reasons to look at the moon. well, there's many, but these are 3 good reasons I thought to do this program. First, the moon is very interesting. There's so many different features to look at. You could spend a lifetime looking at the moon. Secondly, you only need basic equipment to look at the moon. Every telescope loves the moon, and you can even see a lot with just binoculars. And thirdly, the moon is visible everywhere. Even if you're living somewhere in an urban area downtown, the moon doesn't mind. It's always bright no matter where you are. So no need to travel to dark skies to see the moon. And Explore the Moon observing program has 2 versions. There's the binocular one with 40 targets. As you can see here, it has the Marias. Those are the seas, the big black spots on the moon, and the major craters that you can see with a pair of binoculars. They also have a telescope program with 100 targets. And there you get the craters, the Marias, some mountains, and even some of the Apollo landing sites. And for that, you get a certificate, but you also get a nifty pin if you complete the program. So it's kind of neat. And the program is based on, this is a list for the binoculars, and it's based on Q days, and Q days are based on the quarter moon, the first quarter moon. So 0 is the first quarter here. So last Tuesday was the first quarter moon. That was day 0. So now we're Saturday, we're day 4, we're Q day 4. So if you look on the list here, Q day 4, you would see what you need to look at for today. This is just a suggestion, because as the moon phases go by, the terminator, which is the line between light and dark, the shadows are longest there, and that's the best time to look at craters, is near the terminator. So for example, target number 25 over here is over here. And then you have the ocean of storms and the sea of moisture. And as you can see here, it coincides with 4. So this is for today, where the terminator would be near here. And so the position, these are the Q days, and N, E, and S stands for the north, the equator, and the south. So you get an idea about where you should be looking. And finally, the targets are based on Explore the Moon. The Explore the Moon targets are based on a map found in the Observer's Handbook. So that's what these labels are. And if you have the Observer's Handbook, you'll find this map in there. Also, there's a lot of resources available for this program. At RASC National, this program was developed by the Halifax Center, and Dave Chapman was kind of spearheaded the project. So they developed a workbook that explains all of this, all about Q days and the terminator and all that, and that's free for download. And they also have a nice photographic album of lunar features, so that you'll know what to expect when you're looking for craters, because often they'll be bunched together and then it kind of gets confusing, but this will help a lot. So it's also part of the learning process, learning how to observe. And the Montreal Center has, for free download, a PDF for a work logbook. The National Center also has a logbook that you can order for a fee, and it's a physical paper one, which will help you take notes, or you can just use the one from the Montreal Center. So that's just a brief overview of Explore the Moon, but it's really an interesting project. It's accessible to anyone. Well, you have to be a member of RASC to do the program. But it's also good. It kind of focuses your observing. And if you're a deep sky person and you curse the moon when it's large, well, you can just do this program and you'll learn to love the moon. So that's about it for, it was just a short overview of the program, but it's really interesting program if you want to get into astronomy.
Oh, thank you so much, Nicole. That was fantastic.
May I say something?
Absolutely.
Yes.
Yeah, I wanted myself to thank Nicole. And this moon program means an awful lot to me, especially since nationally it is called the I.K. Williamson Lunar Program. I'd like to share with you a little bit about my own following of this program. On October the 8th, 1960, I was introduced to the lunar program by Isabel Williamson herself. And at the time, it was not 5 or 100 objects that we had to spot on the moon. It was 300. It was 300, and we needed a telescope to do it. And I eagerly started to do it. In 1964, I met a friend of mine, and he and I were looking through his 8-inch telescope, David Zakin, may he now rest in peace. But David and I were looking through his 8-inch cave telescope, and he said that he was going to college to finish up, and he was looking for someone to borrow his telescope. And he said, have you done any astronomy in the last 4 years? And I said, a little bit. And he said, uh-huh. And I said, I'd done this and I'd done that. And then I said, I have completed the lunar introductory program. And David looked at me and he said, did you get all 300 craters? And I said, yes. And he said, all the 26 mountain ranges and valleys? And I said, yes. He said, you just borrowed yourself an 8-inch telescope. And that very night, that telescope arrived at my home. I named it Pegasus. And in 1987, I used Pegasus to discover one of my comets. So I just wanted to share that with you. And I would like to recommend, Nicole, that we reinstate as a third echelon of the program the original 300 craters that you can still get in the Discovery Telescope.
Actually, David, the program you're talking about still exists. It's considered an intermediate program. This program here is like the program before the I.K. Williamson Lunar Observing Program. So I completed this one, Explore the Moon. Now I want to do the Isabel Williamson one again. It's considered an intermediate one. Like Explore the Universe and Explore the Moon are considered introductory programs. Then the next level, you have the Messier and the Williamson Lunar Program, which is intermediate. So there's 2 lunar programs. The one you did, you completed the intermediate one.
And that one is 300 craters.
Yeah, and it's still on the national website. So there's 2 different programs.
Wonderful. Well, thank you, Nicole. That was a real treat to hear you do that. Thanks.
And one of the nice things about the beginners program is there is the binocular version of it, which allows for those who don't have a telescope but just get out at night to be able to focus in on the moon just with binoculars or a digital camera to zoom in. And speaking of Isabel K. Williamson, some of you were here at our Townsend last month when we spoke about her having an asteroid named after her. Well, Nicole just name dropped Dave Chapman, and just today it was announced that he had a minor planet named after him. So this is amazing work by some of the RASC members from across the country, not just here in the Montreal Center, but we've been working with a lot of them lately, and it's great to see their work recognized. And speaking of our local center and some of the things that we do, we have our annual general meeting coming up next month on Saturday, November 13th at 7:30 Eastern Daylight Time. It will be by Zoom, so you can join us from anywhere if you're a RASC Montreal Center member. If you are interested in participating in the exec, please let us know as soon as possible, info@rascmontreal.org, because we are running short on the time to declare yourself for any of the positions. We also have our Wednesday members observings happening at Morgan Arboretum with sign up. Next week is Full Moon Wednesday, but after that, it will hopefully happen again if we get some good weather one of these days. We have Zoom clubhouses when Wednesday is a no-go, and most Saturdays when we don't have public events like we do today. And we also have a new InReach section starting out on November 17th, which is citizen science sessions happening during the full moon Wednesday clubhouses. So for more information, again, just email info@rascmontreal.org. And if you want to sign up for memberships, the information is there, or rascmontreal.org/moon/join-us. Our public events, today's one is one we're really looking forward to, and we'll get started with in just a moment. But I do want to let you know that we are doing our spooky nights with our Jack Space Club partners from the John Abbott College students. We will be doing that one by Zoom one more time this year at 2021. It's a Halloween-themed event for kids by youth. So if you know kids who really want to do something for Halloween on Friday night, dress them up in costume, join us on Zoom. That link will take you directly to the event. It starts at 6:30 p.m. so that it's not a late bedtime for the little ones. And as well, in December, after our annual general meeting in November, we will have our next public event, our last one for 2021, which will be on Apollo moon rocks. And the date is incorrect. The date is on Saturday, December the 4th. And it will be advertised well in advance of that. So now for tonight, we have with us our newer member. He joined us in May of this year, Chuck Allen. He is the vice president of the Astronomical League. He is also a past president of the league, a past Air Force officer, and a past lawyer with one of the largest firms in Kentucky. Chuck has been an astronomer since age 7. And at age 7, he started looking up at the night sky, and he has been hooked ever since. As part of the Astronomical League, he has led the founding of the National Young Astronomer Award, and he himself has received the G.R. Wright Award for Service and the League's Master Outreach Award. He has worked with over 450 public programs. He holds a Master Observer Gold status with 41 of those programs completed. And he was recently the co-chair of the Astronomical League's first virtual convention in 2021. Chuck, we are excited for you to join us. We are really happy to have you as a member of the center, and we look forward to you taking us on a trip through the solar system moons and the dwarf planets. So I'll turn it over to you.
Okay, thank you very much, Kareem. I appreciate it. Now, let me apologize for my absence from so many meetings lately. It seems like I always have a conflict on Saturdays, and so I apologize. I will try to make more of the meetings than I have in the past. Let me go ahead and share screen and get started here. And we're going to share sound for a little bit later. Okay. I'm going to stop share and try that again. Hang on just 1 second, please. All right, there we go. Okay, everybody see that okay?
Absolutely.
Okay, great. The first thing I want to say is we're not going to visit every moon in the solar system, so please don't have that fear. And perhaps the way we should start out is discussing where we don't find moons, because this is kind of interesting too. One of the areas we don't find any moons are, of course, around Venus and Mercury, the inner solar system. And the question might be raised, why not? Well, in fact, there could very easily be moons around both Venus and Jupiter. They could host them, that is, but they don't have any. And that has to do really with probability. And the probability is fueled by something called the Hill sphere. And let me describe, first of all, a couple of the spheres or ranges of influence that surround worlds. One of them is something you're very familiar with, which is the Roche limit. And the Roche limit is simply a distance within which tidal forces become so great that they would break up a moon or asteroid or something moving within that range. The Roche limit does vary. It depends on the density of the objects involved, obviously. A lead ball is not going to break up nearly as fast as a moon made of water ice. Here you have an example of a moon that is outside the Roche limit of a planet. And this moon is experiencing greater gravitational acceleration on the front side than it is the back, because the front side's 10% closer to the planet. But so far, so good. But if the world gets closer, as in this example, and these percentages are totally, for example, only, they have nothing to do with the actual Roche limit. In this case, the front side of the moon is 30% closer to the planet than the back side. This causes vastly greater gravitational acceleration on the front side of the moon, which causes it to break up and perhaps form a ring around the planet. So that's one distance around moons, or around planets, I should say, that affects whether a moon can stay a moon. But there's another distance called the Hill sphere. Now here you have, if you can imagine, body A being the sun, body B being the Earth. The Hill sphere distance here, which in the case of the Earth is about 1.5 million kilometers, is a point where the gravitational influences of the sun and the Earth are relatively equal. And if you have a moon that is in the vicinity of body B here, its relationship to this Hill sphere is very important. So let's imagine that we have the Earth sitting in deep space, no sun, no gas giant planets, just in the middle of a void somewhere. We have the Earth. It has a Roche limit within which a world might break up if it came too close because of those tidal forces. But its Hill sphere is arbitrarily large. In other words, if the Earth were sitting alone in a void, you could have a moon orbiting at an enormous distance if it were going slow enough with the correct trajectory. However, if we put the Earth close to the sun, within the sun's Hill sphere, now the Hill sphere of the Earth becomes much smaller because the sun is competing for gravitational effects on moons or asteroids wandering close to the Earth. So in this case, this world here can orbit the Earth because it's inside the Earth's Hill sphere, inside its sphere of influence relative to the sun. This moon out here, though, is going to opt to orbit the sun instead. And so this distance is very important. And if you look at the Hill spheres surrounding Venus and Mercury, you see that they're vastly smaller, especially in the case of Mercury. This makes their hosting of moons much less probable. Doesn't mean they couldn't have a moon orbiting within these Hill spheres. They just don't happen to. But the fact that their Hill spheres are so small is one factor there. This is roughly where the moon is in relation to our Hill sphere, about 1/4 of the way out. If you look at the Hill spheres of the gas giant planets, you see how vastly larger they are than the Earth's. And the reason for this is because A, they're more massive, and B, they're much further from the sun. So the sun doesn't compete for the gravitational influence in their vicinity quite as much as it does with the inner planets. This raises an interesting question. Could an astronaut orbit, let's say, the space shuttle? The space shuttle weighed about 104 tons. So could an astronaut orbit it? Well, if the space shuttle were orbiting the Earth at say 100 or say 300 kilometers altitude, the Hill sphere of the space shuttle would be approximately 120 centimeters. That means the astronaut would have to orbit in a very tight orbit within the space shuttle itself, so that wouldn't work. However, if you take the Earth out of the equation, put the space shuttle in deep space, where its Hill sphere would be arbitrarily large compared to what it would be near the Earth, yes, the astronaut could orbit the space shuttle at a considerable distance if he were moving or she were moving at the proper speed. Now, one question we might have is our moon the only moon the Earth has? Technically, yes, but there is another world that has sometimes been called Earth's second moon. You can see it spelled here in this photograph that was taken by some friends of mine out at the Astronomical Society of Kansas City. But the correct pronunciation of this is 3753 Cruinia. And 3753 Cruinia is an Aten asteroid. It's about 5 kilometers in diameter. It was discovered in 1986. And it orbits the sun in 1-to-1 orbital resonance with the Earth, something like this. So it's considered to be co-orbital, and for that reason is sometimes referred to as our second moon. At its closest approach to the Earth, it shines at magnitude plus 15.8, so it's not an easy target. Now, if we freeze the Earth in this diagram so that it's no longer moving, we see that the actual movement of Cruinia is in a bean-shaped orbit, like this. But Cruinia orbits the sun just a tiny bit faster than the Earth does by just a fraction of a day. And so this bean shape migrates from close to the Earth, back around the sun, back close to the Earth again, in a sequence that goes out and back every 770 years. When it's at the closest approach to the Earth, it's about 12 million kilometers from the Earth. The last close approach was in 1902. The next one will be in 2292. Is it really a moon of the Earth? No, it's orbiting the sun, but again, considered to be our second moon by sun. Asteroids too have moons. Here you see 243 Ida, an asteroid discovered in 1884. It's about 60 kilometers long, and it has a little tiny moon called Dactyl. It's 1,400 meters in diameter. It orbits at a distance of 90 kilometers, and it was discovered by the Galileo mission in 1994. By now, we actually know that there are 24 asteroids that host little moons. One of them, the brightest asteroid that hosts them, is 45 Eugenia, which has 2 moons, one of which you can see here in this image from the Canada, France, Hawaii telescope called Petit Prince. And this is the first moon of an asteroid ever discovered by a ground-based telescope. As you may notice, what we're going to be talking about today is not, again, every moon in the solar system, but moons that have something special about them, something unusual, perhaps a record holder of sorts. So keep that in mind. The next one we're going to look at is Phobos and Deimos, Mars's moons. Now, this is not a comparison of sizes with our moon. This is a comparison of how large they appear from the surface of their respective planets. So if you're standing on the Earth and this is how big the moon looks to you, that's how big Phobos and Deimos, the small one, would look from the surface of Mars. The reason Phobos is interesting is because it is the closest moon to a planet of any moon in the solar system. Phobos is about 22 kilometers in diameter, but look how close to Mars it orbits. Here's Phobos here compared to Mars. This obviously bodes ill for Phobos. It will eventually enter Mars's Roche limit and break apart, as you may recall from our earlier discussion. Phobos orbits Mars 60 times closer than the moon does, the Earth. When we look out at the Galilean moons of Jupiter, seen here from top to bottom, of course, Io, Europa, Ganymede, and Callisto, we think of them as Galilean moons because, well, Galileo discovered them. Or did he? There seems to be some thought based on a document fragment that was identified by a Chinese astronomer who died several years back named Zi Zizong, that perhaps Ganymede was discovered far earlier, long before Galileo. He found a text from an astronomer called Can Ti from 365 AD. It was in a treatise on astrology of the Kalyuan era, the 23rd. And in that, the text read, in the year of Changyan, Jupiter was in Z, which is Aquarius. It rose in the morning and went under the evening together with the lunar mansions Nu, Zu, and Wei. It was very large and bright. Apparently, there was a small reddish star appended to its side. This is called an alliance. Now, Ganymede shines at magnitude plus 4.5. And is the largest moon in the solar system at over 5,200 kilometers diameter. That's 26% larger than Mercury. And it could be detectable with the unaided eye from Earth. Here's how you can do it. If Ganymede is widely separated from Jupiter, close one eye, let a distant tree limb occult Jupiter, you might just glimpse Ganymede or possibly Callisto. So it's not clear whether what he saw was Ganymede or Callisto, and it's not clear why he called it red. But we do know that Mars and no red star was in the vicinity of Jupiter at any time during that year. Speaking of Ganymede, we need to speak of some record that it holds. A Japanese astronomer, Naoki Hirata, recently reported that his team had determined that Ganymede very likely hosts the largest impact structure in the solar system. Now, Ganymede, again, is a little over 5,200 kilometers in diameter, but the impact has a diameter of 7,800 kilometers, greater than the actual diameter of the planet. And it was deemed to exist because of a circular series of furrows that have been found on the world by his team. Now, this will be explored further by the JUICE mission, the Jupiter Icy Moons Explorer mission to Ganymede, Callisto, and Europa, which will hopefully depart Earth in 2022, arriving 7 years later. So news at 11 on whether this proves to be a gigantic impact crater indeed. Jupiter's moon Io is interesting for several reasons. It holds some records too. It's the highest density moon in our entire solar system, made of silicate rock mostly, and it is the most geologically active moon that we have. It has over 400 active volcanoes, 100 of which are taller than Mount Everest, one of which, Sola Montes, is 60,000 feet above the average surface of the world. And when the New Horizons mission passed Io in 2007 en route to Pluto, it took 5 photos that they sewed together to form this image of a volcano called Tvastar, which is hurling material 380 kilometers vertically over the surface and spreading it out over a distance of 700 kilometers on the surface of Io. If we look to Saturn, you look at the Encke division, gap rather, which is a smaller gap outside of the more famous Cassini division, which is wider and closer to the planet. We see that the gap is actually being maintained by a shepherd moon. And this little moon is Pan. It's about 35 kilometers in diameter. And upon studying it close up, we found out it looks a little bit like a raviolo. It was discovered in 1990 from analysis of old Voyager 2 photos, and appears to have this little ring around its equatorial belt because it is collecting particles from the gap, keeping it clear. At least that is the estimate. Saturn also has another very strange moon called Hyperion, which is sometimes likened to a space sponge. It's mostly water ice, and it's the first non-round moon ever discovered in the solar system. And it has extremely low density, only half that of water. And indeed, if you encapsulate the rough surface of this world, you would find that 40% of the interior of it is empty space. Very unusual world indeed. Out at the edge of the brightest part of the rings, the A ring, has a very sharp and well-defined edge that we can easily see in telescopes. And this edge is maintained by 2 little moons called Epimetheus and Janus. Epimetheus is the smaller one, about 116 kilometers in diameter. Janus, the larger, at 180. These are shepherd moons that keep that A ring edge nice and sharp. They both orbit Saturn, but their orbits differ in distance from Saturn by about 50 kilometers. That's all. Now, this is interesting because the inner one, the one that's closer to Saturn, is going to orbit about 30 seconds faster than the outer one. As a result, every 4 years, this happens. Let's say you have, I'll just say the blue world here because they exchange places. We'll have a blue world moving here, and the red one is catching up from behind because it's moving faster. This causes the blue world to slow down, and the blue world pulls the red one forward, speeding it up. And so the red one moves to the outer orbit, and the blue one moves to the inner orbit. And every roughly 4 years, Janus and Epimetheus exchange orbits with each other in this continuous dance. Really strange situation. And here is Enceladus, 310 kilometers, more like 500 kilometers in diameter. It is the most likely harbor of life outside of the Earth, and that makes it particularly interesting. What you're seeing here are Cassini images taken of its geyser systems. It has over 100 geysers that spew methane, ammonia, nitrogen, carbon dioxide, and water above the surface through vents in the ice. Here is a close-up of some of those geysers. Now, this is very important because it means, theoretically, that what we have here is we have hydrothermal vents that are spewing upward into a liquid ocean beneath the icy crust of the world. Methane and other organic particles are captured by the water molecules, and in some cases not. And then as they spew upward through these vents, because of the pressure that builds from the heat, the water vapor spills out onto the surface as snow, just snow ice, and some detection of these organic particles has also been made. The suggestion that there may be a liquid ocean that's warmed by hydrothermal vents that is full of particles of methane, ammonia, carbon dioxide, and other carbon compounds suggests that life could possibly form in that ocean, as it does near hydrothermal vents in our own oceans. So this is a very, very important world for the possibility of some form of life to exist in these sub-ice crust oceans. This is the surface. It is the most reflective body in the entire solar system because of this snow that spews out from these geysers across the surface. And then there's our old friend Titan, the largest moon of Saturn. It is the second largest moon in our solar system, still larger than Mercury. And it has a nitrogen atmosphere. It is the only moon with a dense atmosphere in the solar system. It's an atmosphere that harbors wind, methane, rain, dunes, and lakes and rivers of ethane and methane because of the intensely cold temperatures at the surface, roughly minus 180 degrees centigrade. As you know, we had a lander leave the Cassini mission. The Huygens lander landed on January 24th, 2005. It's the most distant landing that we've ever made as humans. And I'll let you just enjoy the landing now.
2005 begins with the
Can you hear
Earth
this
passing
thumb up?
directly in between the Sun and Saturn, an opposition so perfect that it occurs maybe twice per millennium. Meanwhile, the Huygens probe, quietly entering the Saturnian system, is about to end its 7-year journey. As Huygens approaches, the inner planets cluster around the distant Sun. Saturn appears almost as large as Orion. A few moons are visible as white dots aligned with Saturn's rings, while Titan, its largest moon, is already well resolved. Huygens is destined for Titan, a mysterious world larger than the planet Mercury and shrouded by a thick brownish-orange atmosphere. The details of its surface have never been seen. Huygens' speed increases to near 6 kilometers per second, and Titan's disk quickly obscures our view of Saturn and its more intimate moons. As the probe enters Titan's atmosphere, the heat shield reduces the speed some 15-fold within a few minutes. The main parachute reduces the speed further. 15 minutes later, the smaller stabilizer chute allows a faster descent at first, but slows as Huygens enters the lower, denser parts of Titan's atmosphere. Huygens is approaching a dark valley between brighter, hilly regions. Beyond the hills to the left, 2 dark parallel lines appear, which are later discovered to be part of a vast system of dunes which surrounds the moon. At 21 kilometers altitude, the probe moves through a thin haze layer as seen on the horizon. The bright area near the center top is the glow of Titan's haze illuminated by the sun. A complicated system of drainage channels, some hundreds of meters wide and kilometers long, are seen cut into the hillside. These are probably the result of runoff from methane rain. Stereographic imagery reveals hills to the left to be perhaps a few hundred meters tall, while features in the valley are tens of meters in height. For most of the descent, the probe travels eastward above Titan's surface. However, below 7 kilometers altitude, the motion reverses into a backward westward motion. It reverses again at 1 kilometer altitude, and we move slowly southeastward. Hang on as Huygens lands on Titan's surface near a water ice outcropping ridge. Another westward-looking view of the descent from 31 kilometers shows the area of Titan over which the probe has just flown. This affords us a good view of the drainage channels and apparent shoreline. More dark lowlands appear and a rough pitted hillside to the left. Spectra of the surface suggested the bright areas are water ice, and the darker areas are a type of hydrocarbon mixture that has never been produced in the laboratory. The small white dot in the lower center part of scene tracks our progress over Titan's surface. We see the reversal in direction at 7 kilometers altitude, and we fly over the ridge near where we will land. As we approach the surface, our perspective brings the topography to life. We see that although there are rivers and a shoreline, the basin is dry. Below, there are distinct signs of erosion which crafted the rugged ridgeline. Huygens sinks into one of these gullies. We experience a relatively soft landing on Titan's surface. The view from the surface reveals an amazingly Earth-like picture of a dry riverbed, with distant hills which are a few meters in height. Some seconds after impact, the shadow of Huygens' parachute drifts across the scene. The heat from the surface science lamp in the probe's skin vaporizes methane from Titan's surface, which is about 180 centigrade degrees below freezing. Near the probe, the ground is littered with water ice rocks and smaller pebbles which could be made of water ice, or hydrocarbons, or some combination thereof. Although we now know more than ever about this mysterious world, many questions remain unanswered. Where is the vast reservoir of liquid methane necessary to replenish the atmosphere? Where and how often does it rain on Titan? How does the methane get recirculated into the atmosphere? What materials make up the surface? What processes create and shape the hills, dunes, and valleys?
In case you wanted to see that weather report, there it is. Temperature minus 180 centigrade, wind 1 kilometer per hour, pressure about 45% higher than Earth's. That's about like being 15 or 16 feet deep in water. Humidity 50% methane. No clouds. Sunset 131 hours later. Interesting place. Also interesting is the Iranian moon Miranda. Miranda is a tiny little world. It's about 468 kilometers in size. This will give you an idea of how big Miranda is compared to your homeland. Fit neatly between Quebec and Ottawa. And it hosts these incredible cliffs, the Verona Rupes. They are 19 kilometers tall. What happened to this world is it got destroyed at some point and recollected in a jumble of furrows and valleys and ridges and cliffs, like baby blocks recongealing together. So the question is, might it be fun to jump off of the Verona Rupes? You're thinking, well, the acceleration of gravity on such a tiny world, it's only 1/124th as strong as the Earth's at 0.079 meters per second squared. So it might be kind of fun to jump off. Maybe we'll throw a rope ladder off the top to give us a chance to change our mind. And so we jump. And after 1 second, we have fallen only 4 centimeters. After 10 seconds, we've fallen only 4 meters. It's a very delightful, slow fall, very entertaining. After 35 seconds, though, we're nearing the bottom of the rope and we have to make a decision. Do we grab it or do we continue the drop? You better grab it because the fall takes a total of 11 minutes and 45 seconds to reach the bottom. But by the time you do, you'll be going 200 kilometers per hour. It's like jumping off a 57-story building. Now, this is a Neptunian moon called Neso, and it holds a unique distinction. It's a moon that is 60 kilometers in diameter, and its distinction is that it orbits at a maximum distance of Neptune of 77 million kilometers. It is the most distant known moon from any planet in the solar system. The Pluto-Charon system also, of course, holds a great deal of interest because of the fact that the mass of Charon, which is 1/8 that of Pluto, and it has half the diameter of Pluto, causes them to orbit around a barycenter that is located roughly where the little cursor is, right here, outside of the surface of Pluto. And so they do a dance like this. Now, this is much akin to what happens if you take a child's hands and swing the child around. Most kids, little kids I know, seem to enjoy that. But if you do this and swing around, you'll notice that you too are leaning back, and that the actual center of gravity of your system is something just in front of your chest. And that's what's happening with the Pluto-Charon system. And this dance was actually captured by the New Horizons mission as it approached from a distance of 50 million kilometers. You can see the barycenter marked with a little white X there in the center. Charon is an interesting world in itself. It has a red polar cap. These are tholins, organic macromolecules that have migrated over from Pluto's atmosphere and deposited all over the surface of Charon, but mostly at the pole because it's relatively stationary. So most of it just piles up there. These organic molecules come from largely methane, nitrogen, and carbon monoxide that's pulled off of Pluto's atmosphere by the significant gravity of Charon. Deposits at the pole, ultraviolet radiation from the sun strikes these substances, leaving behind tholins, which have a red hue to them. These are organic macromolecules. There's also an interesting mountain called Kubrick Mons, named after Stanley Kubrick, the director of 2001 Space Odyssey. It's a mountain in a moat. Nobody can figure out how in the world this mountain formed in a ditch, but it's there nonetheless. Pluto also has a moon called Nix, which is the second largest of its moons, and it too has a noticeable reddish area, also thought to be tholins, possibly created when an impactor struck Nix and caused material or regoliths from inside to deposit on the surface and be affected by ultraviolet radiation also. These little moons of Pluto tumble chaotically. They tumble chaotically because of this barycenter dance that Pluto and Charon do. It just whips up gravitationally the entire environment, causing these moons to tumble and rotate at variable speeds. Indeed, Nix, that you see here, has increased its rotational speed 10% in a space of just 10 years because of this. Well, what about the dwarf planets beyond Pluto? They too have moons. Eris has a moon called dysnomia. Dysnomia, by the way, is a condition where you forget people's names. So I suppose they were having trouble coming up with a name, and so they just named it dysnomia. I don't know. Makemake has one called MK2, and Haumea is known to have two moons, seen here, Namaka and Hi'iaka. And beyond the actual dwarf planets, other TNOs also have moons. Quaoar has a moon called Wewat. Orcus has a moon called Vanth, which is a very large moon. It's about 450 kilometers in diameter, and it and Orcus behave very similarly to Pluto and Charon. They share a barycenter that lies outside the surface of Orcus. Gong Gong here in this animation shows evidence of a little moon. You can see it right here, called Xianglu. And Salacia has a moon called Actea. So that's it. Those are the most interesting moons that I could come up with for the solar system. But what if we look beyond the solar system? What if we look to the stars? Any hope there? We've got 218 known moons in the solar system, but could there be others that we could find further away? Well, the answer is yes. Here we have a star called Kepler 1625. It's a magnitude plus 14 star in Cygnus, lies at a distance of 8,175 light years. And it's known, because of a transit study done by the Kepler telescope, to have a Jupiter-sized planet, which when it moves in front of the star, as you see in this image number 2, causes the brightness of the star to dip noticeably. When this Jupiter-sized planet clears, the brightness returns, but then there's a second smaller dip caused by what's believed to be a Neptune-sized moon orbiting the Jupiter-sized planet. And so we have a detection, we think, of a moon beyond our own solar system. But we don't want to forget, of course, our favorite moon, a moon that occupies between 29 and 34 minutes of arc of our sky. It shines at magnitude minus 12.74 at full moon. The sun's 1.3 million times brighter. We believe, scientists believe, that the leading theory for the moon's formation is that the Earth was struck by a Mars-sized impactor about 4.5 billion years ago. It's thought that this impactor had been parked at either the L4 or L5 Lagrangian point ahead or behind the Earth, and that the movement of Venus in its orbit disturbed Theia, the name of this impactor, and caused it to spiral in toward the Earth, striking it at a glancing blow, merging its core with ours, explaining our very large core in the Earth, and giving rise to the formation of the moon. The Planetary Society has recently published a paper, though, suggesting that this impact may have occurred in two stages, actually two impacts. That is, that Theia struck the Earth at a glancing blow, ripping material out, and then the material came back for a second impact, collected back, struck again, and then started rotating. And the central mass rotated to become the Earth, and the material left out here continued to congeal to form the moon. We know that our moon is an extremely important place for us. It's a very important object in our lives. First of all, we see that it has two very distinctly different sides. And this is because when Theia struck the Earth was very molten, very hot, and the moon was much closer to the Earth than it is today. And this heat heated the side of the moon that was tidally locked facing us, causing that surface that faced us to be thinner and more subject to asteroid impacts, allowing lava to spread out over the surface. Whereas the backside, the far side of the moon, was allowed to cool a little bit more and became thicker crusted. We also rely greatly on tides caused by the moon. Here you see in the yellow the tides that are caused by the sun, and in the light green the tides caused by the moon. The dark green represents the sum total of those tides. Here we have a situation where we have the new moon, where the moon and sun are aligned together, pulling what's called the spring tide, which is the biggest tide we have. Now, why the bulge on the other side? Well, if we kind of flip this image vertically, we can see why. You have the water on one side experiencing greater gravitational acceleration toward the moon here than the Earth is. And you have the water here experiencing less gravitational acceleration toward the moon than the Earth is. And so the Earth is literally falling out from under the water on the backside, the antipodal point, giving rise to the antipodal tides. At a quarter moon, the solar tides and the lunar tides sort of compete with each other. The solar tide pulls a little bit out this way. It's only about a third as strong as the moon's gravitational influence on the water. And the lunar tides are at 90-degree angles to it. So this is called a neap tide. It is not nearly as significant. These tides are important for another reason. Tides actually have caused the Earth to slow down. At one time, the Earth rotated every 6 hours. But because the tides were pulled out toward the moon and the Earth's rotation carried the tidal bulge ahead of the moon, this tidal bulge yanked the moon forward, causing it to speed up and move into a higher orbit. And so slowly over time, not only has the moon moved away from the Earth, but the Earth has slowed down because this water being pulled by the moon acts as a brake shoe counteracting the rotation of the Earth. So it has slowed the Earth's rotation down to 24 hours and moved the moon out to a considerably greater distance. Even today, the moon gets about 1.3 centimeters further away from us each year, which means in about 1.2 billion years, we won't have any more total solar eclipses. The Theia impact gave us perhaps the axial tilt that we have, which gives us our seasons. So that was a very important event caused by something you might refer to as a moon. And the moon today actually stabilizes our axial tilt. It keeps it within about 3 degrees of 23.4 degrees over a period of 41,000 years. Without the moon, that variation could range between 0 degrees and 80 degrees because of the influence of the gas giant planets in the outer solar system on the Earth. So the presence of the moon is a stabilizing force, keeping this axial tilt in check and allowing us to have the seasons that we do and not experience chaotic seasons, which would be disastrous for us. Obviously, the existence of the moon keyed early astronomers into understanding that other worlds were spheres and understanding the phases that they were observing with Mercury, Venus, and Mars. The impact on species of the moon is unquestionable. Here we have sandhoppers who rely on 2 compasses, a sun compass in their brain and a lunar compass in their antennae, to try to determine when and where to be on the beach. If they're too far up on the beach at a low tide, for example, they'll dry out and die. If they're too low on the beach at a high tide, they'll be swept out to sea. So they depend on the moon very greatly to manage their locations. Mass spawning of corals occurs just after full moon in October, November, and December of each year. Petrels do their pre and post breeding migrations to Réunion Island. They arrive at the full moon every time. The joint pine dewdrops form during full moon because that's the only time the light from the full moon will cause them to sparkle and attract pollinators. And even dung beetles are sensitive to polarized lunar light, which helps them move in straight lines back to their burrows, helping them survive. And they've been tested under non-polarized artificial light, and when exposed to that, they move in circles. So it's very, very important to us that we have the moon that we do. And in closing, I'd like you to enjoy that moon just a little bit. A friend of mine named Mark G. in New Zealand did a video several years ago. He set up a video with a telephoto here in Kelburn Park in Wellington, New Zealand, and aimed his instrument at a hilltop lookout on top of Mount Victoria, clear across the city, a distance of about 2,500 meters away, and made this video that I think you'll enjoy in closing. Thank you very much.
Thank you, Chuck. That was fantastic. David is clapping as well. That was it was full of amazing information about all of those different solar system moons and the exomoon. And actually, there was a question sent to me asking if you could mention why the transit, they would think that it's a moon and not a ring around that exoplanet.
Well, first of all, they're not absolutely certain about this, but the moon is creating a very discrete second dip in magnitude. And it's a very sharp second dip. And you would not expect that from a ring. And in fact, this moon is a huge one. It's the size of Neptune. So it's,
Wow.
creating a substantial dip, not as large as the primary planet.
So a super Jupiter with the Neptune around it. Wow.
Yes. Yes.
That's incredible.
There's even more. There's a third dip, a tiny one, that has led them to believe that maybe the Neptune-sized moon may have a little moonlet of its own. So, but that's still highly theoretical at this point.
A moon around a moon around a moon.
Yeah, it's possible.
See, it is.
It's all about the Hill spheres. As long as that tertiary moon is within the Hill sphere of the secondary moon, it will stay in orbit about it.
Well, when you mentioned the other object that's sometimes referred to as Earth's second moon, I thought you were going to talk about one of the objects in one of the Lagrangian points ahead and behind the moon's orbit, because didn't we find something around asteroid-sized in the second Lagrangian point trailing behind the Earth?
Yes, and I think they're a bit smaller, as I recall. Cruinia is the only one I've heard so far referred to as the second moon. But I think they're really, if you count every little asteroid that would be following or ahead of us at the Lagrangian points L4 and L5, there are, I can't remember the number, it's several dozen at least, perhaps more.
And Isaac was just asking if you had any thoughts or any word about Triton you wanted to mention.
I thought about Triton, of course, is one of the other major worlds besides Enceladus and Io that are geologically active. There are geysers on Triton as well. And I thought about doing that. And I just had to.
There's too much.
There are 218 of them. I didn't want to say, okay, here's number one. We'll go through all 218. I couldn't do that. But Triton is an important moon. It's a very large moon and very geologically active with geysers as well.
218 and counting.
Yeah. Yes, very definitely.
So I have a question about the moons of Jupiter, but before I get to that, Robin was mentioning how interesting it was to watch the moon rising from the southern hemisphere, because just orienting yourself, what do you think about the shapes that we see on the moon? And the man on the moon versus, Wilma from the Flintstones versus the two lovers dancing. What do you see when you look at the moon?
I don't really pay that much attention to that. I've always sort of seen sort of a crescent-shaped man on the moon. The bright part with a protruding nose from one side. I guess that's the thing I notice the most, but it's. I have to search for some of those others. There's a cow jumping over the moon. There's like you say, Wilma, the woman in the moon, the man in the moon. There's a couple of other, rabbit in the moon, I think is another one. Some of these are actually listed in the naked eye portion of one of our basic lunar programs.
Yeah, we have this on our moon guide that we give out to people as well.
Yeah.
So with Jupiter, I wanted to ask you, because when you were showing the schematic of Janus and Epimetheus. Is it Epimetheus? No, it's
Epimetheus and Janus.
Epimetheus.
Right.
So Epimetheus is normally linked with Prometheus in the mythology, not with Janus. It's interesting. But you were showing the orbit, and the orbit was clockwise. It was retrograde. Are they retrograde moons, or was that just the orientation
No,
of
I
the
don't
schematic?
think so. I think it was just the orientation of the schematic
So
in that case.
Jupiter has so many different groups of moons, some going retrograde, some going prograde. Is there anything to do with, is it just how they're caught, or is it something to do with the distance in the Hill sphere around the planet?
Well, obviously, if it's caught going in a certain direction, if it's incoming from the backside, it could easily orbit in an opposite direction.
Is that the case with Triton then? Is it because it came in from the backside that it's retrograde?
I don't know.
Yeah.
I don't know the answer to that.
Okay. So we've had some awesome comments in the chat. I think at this point, it would be great to just have an open discussion. So I'm going to thank you from the center for this awesome presentation.
Sure.
It was great information. And I hope that we'll be able to have more talks from you, not just for public talks, but also just in the clubhouse. We tend to have members share a little bit of their own experience in the clubhouses or tricks and tips that they have, advice they want to give each other. So I do want to thank everyone for joining us for International Observe the Moon Night. Before I open it up for discussion, I just thought I'd take one more moment and just share with you live an image of the moon right now. We're at about an 86.5% waxing gibbous at the moment. Beautiful imagery on not just Tycho, but also along that terminator. You can look for all of those Q4 targets that Nicole mentioned to us earlier. And so I encourage you later tonight, especially if you're somewhere like we are here with rain and clouds, to take advantage of the live streams that are there on the internet. Thank you again for joining us, and welcome to join us on Spooky Nights, October 29th or December 4th for our Apollo Moon Rocks talk. I'm going to end the recording and I'm going to open it up for just an open discussion.